Hello students! By the end of this video, you should be able to divide polynomials and then interpret the solution. So yes, that means we are going back to the process of long division that you used to know and love. But this time we are going to do it with variables. So first let's remember what long division actually is. Just making up a problem at the top of my head, but let's say you want to divide 3 into 1,213. What would you do? Okay, look for factors that 3 goes into. 3 does not go into 1, but it goes into 12. How many times does 3 go into 12? We would say 4 and write it above the line. Then you'd multiply. 4 times 3 gives me 12. Then you would subtract. 12 minus 12 gives me 0, and I just repeat the process. So 3 does not go into 1, but it does go into 13. How many times does 3 go into 13? Well, it goes in 4 times. 4 times 4 gives me 12. Or excuse me, 3 times 4 gives me 12, then I'd subtract, and I'd be left with 1. 3 doesn't go into 1, and there's nothing left to bring down, so this would be my remainder. And you can either write this as 44 remainder 1, or as a number, 44 and 1/3, because that 1 could not be divided into 3 pieces. The process of polynomial long division is exactly the same as the process of long division, but with variables. Okay, so what you're going to do is you are going to take x plus 2 and try and divide it into x cubed plus 3x squared minus 4. So first you want to look at how many times this factor goes into what's over here. Now I don't necessarily know how many times x plus 2 goes into this, so we're just going to concentrate on the first term and see how many times that goes into each term. So how many times does x go into x cubed? Okay, or if you think about it from the long division example I just did, we were looking for what number could I multiply 3 by to get 12, and the answer is 4. So what could I multiply x by to give me x cubed? The answer would be x squared. Okay. Then what we did is we multiplied these two numbers, wrote it below, and subtracted it. I'm going to do the same thing for polynomial long division. In order to multiply, though, I do have to multiply by both terms. So I'm going to multiply x times x squared. It gives me x cubed. X squared times 2 gives me positive 2x. And now I'm going to, positive 2x squared. Now I'm going to subtract these. So again, the process is the same. Figure out how many times it goes in, multiply it out, subtract. And if you did it correctly, these should cancel. So what's left then is I have only a squared term instead of a cubed term. So I have 1x squared. Continuing on, I want to repeat the process. So how many times does x plus 2 go into x squared? Or how many times does x go into x squared, which we'd have to multiply it by plus x. Distribute this out. X times x gives me x squared. X times 2 gives me 2x. Okay, I want to bring that negative 4 down, so I have something to combine with. Now if I go ahead and subtract, these will cancel out, but notice I can't combine these like terms. That's because we're missing a term if I'm looking in order here. So I have an x cubed, an x squared. I'm missing an x term. So for the purposes of combining like terms, I want to fill in how many x's I have as a placeholder. So really I have 0 x's. And you can fill that in up here to make it a little bit easier from the start. Now I can combine like terms, subtract them out, those canceled, and I have 0x minus 2x, and that just gives me minus 2x's. Now I can repeat the process and bring down my minus 4, and my last term should wind up being constants. So how many times does x go into negative 2x? And the answer is I'd have to multiply it by negative 2. So if I distribute that negative 2 out, I have negative 2 times x gives me negative 2x, and those are the exact same thing, so we know we did it correctly. Negative 2 times positive 2 gives me negative 4. If I subtract those, if you prefer, you can distribute out the negative and make this plus, and then a negative is positive. So really everything cancels out here and you get 0, which means I have no remainder. So my final answer would be x squared plus x minus 2. Now let's think about what this 0 as a remainder means. It means that everything divided in evenly, or everything went into the polynomial. So if I multiplied x plus 2 times x squared plus x minus 2, what would happen? I want you to go ahead on your note sheet, distribute this out to the side, and see what you. Hope you pause the video and multiply that out yourself. And you should have gotten x cubed plus 3x squared minus 4, which if you notice is the same answer as my original polynomial. So what it means to use polynomial long division is you can actually see whether or not this is a factor of our original polynomial or our highest degree polynomial. Since there's no remainder, it divides unevenly. That means it's a factor. Just like if I were to divide 4 into 12, I would get 3. Okay, and there'd be no remainder. That's because 4 is a factor of 12. Same thing here. X plus 2 is a factor of x cubed plus 3x squared minus 4. So polynomial long division is really useful because I can actually use it to factor. So if I couldn't factor this x cubed plus 3x squared minus 4 using the methods we learned, I could divide in some factors, and then our final factorization, since x plus 2 is a factor, would be x plus 2 times x cubed plus 3x squared minus 4. Okay, these are equivalent. Factored form, standard form. Cool, right? Unfortunately, you do need to remember long division to know this process. And so people came up with another process called synthetic division. That's a little bit easier in terms of the process. Basically, synthetic division is long division without the variables. I hope that without variables excited you all, because I know that this process was a little bit tricky because you had to think about variables and long division. So we came up with synthetic division. It's a little bit easier. Okay, so in order to do synthetic division, we focus on the coefficients and the numbers that we see. So we're going to divide in x plus 2, but if you set this equal to 0 to find what the actual x-intercept is, subtract the 2, the x-intercept would be negative 2. So instead of dealing with the factor as it is in its polynomial form, we're going to deal with the factor as it is in its 0 form, like the 0 is at negative 2. So I'm going to go through this process pretty quickly because it's simple. I will write the steps out at the end. The first thing you're going to do is you're going to make your box number with what you're dividing into the polynomial. So I'm going to divide in negative 2 into this polynomial. Now instead of looking at the variables, I'm going to focus just on the coefficients. So the coefficient here is a 1, we have a 3 on the x squared, and we have a constant of negative 4. However, if you remember back to the long division process, I needed to fill in how many x's I had, so our terms lined up. You need to do the same thing in synthetic division, and this is the number 1 mistake. So star this. You have an x term, or an x cubed term, you have an x squared term, but you're missing your x term. And your synthetic division needs to go in order, so I do need to fill in a 0 for the x term. So now I have cube, squared, x, and 0 x's. On with the process. I'm going to draw a line, and first thing I'm going to do is bring down the first term. Okay, now this is kind of like the long division process where you divide things in, but you don't actually have to divide in this process. All you're going to do is multiply whatever's below the line with the box number. So 1 times negative 2 is going to give me negative 2. Whatever you multiply goes above the line. And then you add down the columns. So 3 plus negative 2 gives me 1. And you're just going to repeat this process. Multiply with the box number, gives me negative 2, add down the column. 0 plus negative 2. Again, multiply, you get 4, add down the column, and you get 0. And that's pretty much a synthetic division process, except for the fact that I didn't really answer the question because I didn't write a polynomial at the end. So your answer when you divide polynomials should always be a polynomial. And just as a side note, if I'm dividing an x cubed by an x, if you just multiply this out x 3 times, you can cancel 1x, you should end up with a quadratic if you divide out 1x. That's a good way to check your work. So keep in mind your final answer of this problem should be a quadratic. Now the way I remember to label my answers, I took the coefficients out for a second. Now I just have to put them back in. So this was my constant, this was my x, this was x squared, this was x cubed. If I remember this order, I can kind of think about what my solution would be. The only difference is my divided polynomial should be an x squared as the highest term. So this should be an x squared. Instead of going left to right, I always go right to left. It's a little bit easier because you don't have to think about what the highest term is because it goes in order. Now, whenever you divide something, the final answer is always your remainder. And since my remainder is 0 in this problem, that meant that this was a factor of the polynomial. which my remainder in this problem should be 0 as well because it's the same problem. So the last term is always your remainder, and then it just goes in order. This is my constant, whatever's to the left of the remainder, then my x term, then my x squared. If I had another term, it'd be x third, x fourth. I could just go in order. And the reason it winds up being in order is because you put the coefficients in order, you filled in a 0 for your x term. So you have all those terms represented here as well. Of course, unless there's a 0 here, then I'd have 0 x's. So my final answer would be x squared, or 1x squared, but I don't need to fill that in, plus 1x, so I'll just call it x, minus 2. Technically remainder 0, but you don't need to write that because it divided in evenly. So if I divide in x plus 2, I would get x squared plus x minus 2, which amazingly enough is exactly the same thing as we got long division, but it was a lot quicker and a lot less room for mistakes. Okay, I'm going to pause the video and write those steps in over here. Write down any questions you have right now before I come back with the answer. Okay, here are the steps. You should pause the video and write these down. So remember, first I determined the box number, then I list out these coefficients. I brought the first coefficient down. Anything below the line gets multiplied with box number and written above the line. Then I add down the columns, and I just keep repeating this process until finally I could rewrite my solution as a polynomial, going from right to left. Any big mistakes I wrote in red, so make sure you fill in 0 for any missing terms. Go right to left when you're renaming, starting with remainder, constant x, x squared. And I guess a 9th step would really then be to interpret your answer. So think about, if 0 is a remainder, what does that mean? Versus if you have a number here, what would that mean? So let's say my remainder for a quick second was 1. I might then write my polynomial as x squared plus x minus 2 plus 1 over x plus 2, because that 1 couldn't be divided in. Just like in this problem, I wrote it as my remainder 1 over what the divisor was, because I couldn't divide those. Something to think about. Obviously, that's not the answer to this particular problem, but it's something that may come up. So there's a problem for you to try on your own to test your skills. So think about that. Write down any questions you have. Make sure to answer your summary. Have a good night.